Hey everyone, and welcome to Dr. Abu Art in Academy channel. Today we are going to discuss part 3 of seminar number 7 of the University of Debrecen and the Biostatistics subject. So in our video today, we are going to discuss about the T distribution and why we have T distribution. We had Z distribution. Why it is not enough? Because in rare cases only we have the sigma of the population. In many of the case, most of the case, we don't have sigma. So how to deal with this? So we are substituting it by using the standard deviation for the sample. And instead of having the standard deviation for the population, we are using for the one for the sample, okay? So instead, we calculate the standard deviation in our sample and use it to estimate sigma, okay? By having this extra or additional estimation or assumption, we are adding a new uncertainty. Okay, this new uncertainty to our conclusion, to our inference. Okay, because all these approaches are inferential approaches. Okay, in order to arrive to a conclusion, so we are adding more uncertainty. So the conclusion which will be withdrawn, it will have more and more uncertainty, and this assumption of using standard deviation instead of standard deviation of the sample, okay, which is S, or sometimes called SD, standard deviation of the sample instead of sigma, okay, we have modified the formula of the Z distribution and just added S standard distribution of the sample instead of it. So it will be X bar minus mu divided, instead of sigma, it will be standard deviation, okay, of the sample, okay. So because we have altered this one, so now we convert it from something called Z distribution to T distribution, and we have tables for T distribution, so we can use the tables of the T distribution. So this T distribution was discovered by William Gossett, okay, very long time ago. He already born in 1876 and passed away in 1937, okay, and it was published by one of his statistics students, okay. So the point here said, okay, now we will use the standard deviation instead of sigma, okay. So how we can improve the accuracy? It says that when we use a large number, when n is very large, okay, when n is very large, the standard deviation of the sample has n number, and if this n number increased a lot, it became 100 or 1000 or 300 or 500, the sample, okay, so the quality of the estimate become very good. So the standard deviation will be very accurate, okay. The standard deviation will be very good estimate for sigma, for the standard deviation. It will be very close. There was no big difference. So the uncertainty will be reduced if the n is very large, okay? And that's why it will be used in the T distribution. So T distribution used large number of n's, okay? It depends on large number of n's to reduce the uncertainty which we may have, okay? And in this case, the estimate, the T distribution will be very close to the normal distribution in case of n is very high. So if we increase the number of n, the number of individuals or elements in the sample, so our sample will be very, very close to the normal distribution. So we have some properties of this T distribution. So T distribution is similar to Z distribution. As we can see here, this is the T distribution in green color, which I'm highlighting in green color. It looks like or similar to the normal distribution, but if you do this one, we'll find that this green color, it has a tail, okay, has a broad tail here, okay, broader tail, okay, like a tail. The other side also, it has a broader tail, okay, bigger tail, okay. So T distribution are similar to Z distribution but have broader tails. There are many T distributions, okay, it depends on the degree of freedom. So as far as I'm increasing the degree of freedom, it will go very close to the Z distribution, okay? And even it will look like it. So if we do this green color, And let us look here now. Okay, see, this is infinite degree of freedom. So it became equal to the Z distribution. So the Z distribution the Z distribution became T distribution became the Z distribution in case if we have infinite number of degree of freedom. If I have lesser number like 9 or 10 or 15 or 7 lesser number, it will be very close because I have big number also of degree of freedom. 9 is a big number also, so it will become very close, but it will not be equal to the infinite. It will not be equaling to the Z distribution. It will have some little gaps. Okay. If I reduce the degree of freedom to 1, for example, so I'll have the normal T distribution. See, this is the T distribution with the tail, with the broad tail. So if I have the degree of freedom only 1, it will be T distribution with a broad tail. If I have 2, it will be little closer to the Z distribution. Until I reach infinite degree of freedom, it will be equal to the Z distribution. So as far as increase the degree of freedom, as the degree of freedom increases, T becomes increasingly very like and closer to Z distribution. So looking at this example, which is T-test, it is same as Z-test. So we're going to use the same methodology, except that we'll use T-table instead of the normal distribution, Z-tables. T-tables, we have alpha. Okay, and we have the degree of freedom. Degree of freedom equals n minus 1. Okay, so let us start this example. In this example, a study conducted a few years ago claims that an adult man spend an average of 11 hours a week watching sport on television. A recent sample. Okay, so here the average of the population is 11. So mu equals 11 hours watching. There is a sample of adult, okay, 16 adults. So n equals 16. 16 adults men shows that the mean time they spent per week watching the sport on the television is 9 hours. So this is the mean time for the sample. Okay, so it would be x bar equals 9. With the standard deviation 2.1. So here still he's still talking about the sample, the mean of the sample of 16 people. Their mean is 9, and their standard deviation is 2.1, which is S or SD. You can call SD or S as you like. Okay, equals 2.1 hours. It is not sigma because this is not for the population. Then he gave us alpha. Test at the 1% significance. So it is not 5% here, it is 1% significant level. So alpha equals 1%, 0.01. Okay, whether currently all adult men spend less than, so he want to test less than 11 hours. So his H null and H alternative. H null will be opposite to what he want to prove, and H alternative will be exactly what he want. So he said that the men will spend less than 11 hours. So H alternative, okay, will be mu less than 11 hours. This is the alternative, and the H naught will be the opposite. So mu greater than or equal to 11. So once we got this, as I told you last time when we dealt with the Z test, just we wrote H naught and we'll use the H alternative. Okay, so he wants mu less than 11. Okay, so let us look at this graph. Less than 11 means that it will be this side to the left. Okay, to the left. So my significance level, okay, or rejection zone will be to the left, because mu, I'm checking the alternative, mu less than 11. So less than will be this side. Okay, so it will be to the left. So here this will be the rejection zone. What is the area here? It is 0.01, 1%, okay, 0.01. So I need to get Z critical and Z calculated. So Z calculated, in this case it will call T, because this is T test, not Z test, okay? And here Z also, Z critical will call T critical. So here I have to get T critical from the graph the same way, but instead of getting Z, we'll get T. And here instead of getting Z, it will be T. So T equal, or Z, the previous Z, X bar minus mu divided standard deviation, which was sigma. In this case, it will not be sigma, it will be a standard deviation, because T, we don't have sigma, divided the square root of N, okay? So I have X bar, which is 9, minus mu, which is 11, divided the standard deviation, which is 2.1, divided the square root of 16, okay? So the answer will be minus 3.8. So this my T critical, okay? So T critical equals minus 3.8, okay? So coming to the normal distribution, or in this case it will not be normal distribution, it will be the T graph, okay? I have alpha equal 0.01 or 1%, okay? And what is the degree of freedom? Degree of freedom, n minus 1. N in my case 16. So n minus 1 would be 15. So my degree of freedom would be 15, because T distribution table is different than Z distribution table, which as shown in the next page. So here, if you look at the T graph, okay, you'll find degree of freedom. My degree of freedom, n minus 1. N 16 minus 1 equals 15. So I have to look only at this line. Okay, only at this line, which is my degree of freedom, okay? Okay, so it would be 15. And then, what is my alpha? Alpha 0.01. So, my T value, which is equivalent to Z, so here I will not get the probability. So in the T graph, you are using the degree of freedom and alpha to get T value, or which is equivalent to Z value, to get the Z value or T value, okay? So we're not getting the probability. So the table here and the Z distribution, it was including the probability, the area under the graph. But in the T, it includes T values, okay? Which is equivalent to Z values. I hope it's clear, okay? So my T value, in this case, I'll go degree 15, okay, 0.01. So T value will be equal to 2.602, okay? Okay, so here this will be, but here as I can see from our graph, it is to the left. So this graph gives you the value because it's symmetric, okay? So the same value to the right and same value to the left, they are the same, okay? So here, if it is here at 1%, 0.01, it will be 2.06. If it is to the left, it will be negative. Mine is on the left, because here we identified at the beginning, it is on the left, so it will be minus 2.602. 602, okay? So T equals minus, in this side, it will be equal minus 2.602, okay? So this is the T critical from the graph, critical. What about the T calculated? T calculated was minus 3.8. So minus 3.8 will come here, somewhere here, okay? It says 0, minus 3.8 will come here. So inside the rejected zone, okay? So the null hypothesis will be rejected, okay? Minus 3.8 here, and this is minus 2.6. So reject the H null, okay? H naught or H null hypothesis will be rejected. If H naught rejected, it is error type 1, okay? It will be a type 1 error, okay? The conclusion here that H naught rejected. This means that H alternative is not rejected. H alternative is matching with what the researcher said, okay? So what the researcher said, that the adult mean spend less than 11 hours, would be correct, okay? because H null is rejected, so H alternative, which is matching with the physician or the researcher, it is right. Okay, so how to determine the p-value? In that test, we used to say that the p-value equals to, we take z and find the value of this z in the tables. Okay, so here we'll take the calculated t, not the calculated z, because we don't have calculated z. Calculated t in this case, it's minus 3.8. Okay, this is the calculated t calculated. So we have to take it to the table and see. Minus 3.8. Let us go to the table back and see. Let us clear everything here and see what is this. So because it is symmetry, so 3.8 or minus 3.8, it will be the same. Okay, so I look for 3.8 or minus 3.8. Let us look here. It must be in the degree of 15, because this is my degree of freedom, 15. So degree of freedom 15 in my case. So I have to look here in the degree of for 3.8. I don't have 3.8, but I have here 3.7, 3.733, and 4.073. Okay, I have these two. Okay, let me highlight them. And these two values. Here, the values here, as I said, it is not the probability. Here the t values, the reading. So from where can I get the probability? Alpha is the probability, okay? So the significance or alpha is the probability, okay? So I have to get the reading of alpha. So let us take this one. What is the probability here? If it was this one exactly, so we can take the reading and we see the probability equals 0.001. If it is this one exactly 3.8, we'll say that it is P equals 0.000305. But unfortunately, it is not this one and it's not this one. It is something in between, okay? Something between them. So we can say that the probability is greater than or less to. Probability is greater than the smallest one. This one is smallest, 0.0005. And greater and less than 0.001. It is between them. Okay, it could be somewhere in the middle, maybe to the right, to the left. I can leave it as an interval, or I can approximate it and get the value. Okay, here in the problem he put it as interval. Okay, on this example, the manufacturer of a certain brand of auto batteries claimed that the mean life of these batteries is 45 months. So this is the population. So the mean would be 45. Okay, a consumer protection agency. In each country there are some consumer protection agencies which protect the consumer. So that wants to check this claim to make sure it's right or wrong. Okay, they're cheating the people or it's right. The battery life cycle mean life is 45 months. So they have taken a sample of 25 batteries, so N equals 25, okay, such batteries, and they found that the mean of the sample, so this is X bar, equal 43.75, okay, the mean of the life cycle, okay, with standard deviation of the sample, which is SD or S only, as you like, 4, okay, and say that alpha, the significance level equals 5% or 0.5, we can write it 0.05 one time, no need to change it again. Okay, you would conclude that the mean life of these batteries is different from, so he did not say more or less. So here H alternative will be what we want to prove, okay? So we want to prove that it is not equal, okay, different from, not equal to 45 months. So H naught will be the opposite, okay? We'll say that it is equal to 45 months, okay? I hope this is clear how we get arriving to H naught and HA, okay? Then what to do? We have two things. First, to calculate, because here I have the standard deviation of the sample. I don't have the standard deviation of the population. So it will be T test, okay? It will not be S test, okay? So I have to calculate T or Z, but here in this case called T. T equal X minus mu, X bar minus mu divided sigma divided square root of N equals, okay, it's written here already. So X bar 43.75 mu 45, okay, SD standard deviation. Okay, so here we don't have sigma, so it will be SD, okay, SD equal 4 square root of 25, which is 5, so the answer will be minus 1.56. This is called T calculated. Okay, then he told me that the alpha, okay, is 5%, or the significance level is 5%. So here what I'm saying, that I say that it is not an alternative. I told you that we'll forget about this one and we'll work on the alternative. Not equal. Not equal means two tails on the two sides, okay? So it will be half here and half here. Okay? So it will be not equaling the alpha, so I have to work here. And so I will have 2.5 here, 0.025, and here 0.025. This is the area here, and this is the area here. I need to find T. Same way we find Z here and Z here. They will be equal because there's a symmetry, so we need to find one of them. Since we are dealing with T, so I need to know the probability, which I have. This is the area, which is 0.025 from this side or from the other side, okay? That's also 2.5, okay? From this side or from the other side, 0.25. I need to know also the degree of freedom. Degree of freedom equal n minus 1. N equals 25, so the degree of freedom will be 24. So I'll go to the table at 24, okay, as you can see, and 0.025. I'll get the answer from here, which would be 2.064, okay? 2.064. So this is T. Let me T calculated equals minus T critical equals 2.064. So it will be from this side 2.064, and from this side minus 0.2.064, okay? So if I want to plot this one, minus 1.56, so minus 1.56, it will be up to here, okay? So it did not reach the rejection zone. So if it's not came into the rejection zone, means H naught, the null hypothesis, is valid. It is not rejected. So let us see it here in detail. Okay, so we get here the answer just to plot the 0.25 from the two sides, okay? And then he calculated from the table here that the T1 and the T2, this is T1 and this is T2, the same value, but one of them negative and the other one is positive. And then the next slide, he just put the one minus 1.65 here, which it did not enter into the rejection zone. So that's why he said here, we don't reject H naught. If we did not reject H naught, means that the proposal or the assumption made is wrong, the alternative, because the alternative proposal is the assumption. Okay, we said at the beginning the alternative hypothesis is the assumption which we have, which we are checking, and H naught is the opposite to it. Okay, so the conclusion that the data does not support the research hypothesis, that the mean life, and we have to take it exactly from the question, that the mean life of these batteries is different from 45. We can write it as it is. Okay, different from 35. Okay, I hope it's clear. Then if you ask us to calculate the probability, so the probability I have to find, in order to calculate the probability, I have to find the calculated t, which was minus 1.56 or positive 1.6, because I have both of them here. Okay, I have t here and t here. So here, this is the t1 and the t2, and the same way here, I have this minus 1.6, and for similarity in the table, I have the same one here, 1.56. Okay, so if I have 1.56, okay, the probability of it will be equal to the probability of minus 1.56. So I'm going to the table. I have to use the same degree of freedom, which is n minus 1. N was 25, minus 1 equals 24. So I have to go the same line 24 until I see 1.56. Let me check. Okay, 1.56. Until I see 1.56. So go to the table and check 1.56. So here at degree 24, 1.056. So our calculated t equals minus 1.65, which also from the other side also. So I have 2. Here you have to be careful, I have 2. So whatever the probability we'll get from the table, it has to be multiplied by 2, because we have 1 on this side. If you consider 1.56 from this side, we have another one from the other side. So we have to multiply it by 2, because these 2 tails, okay? So let us check 1.57 or minus 1.7. In the t tables, we have positive. So we'll go here. And the degree of freedom 24. So we have to stick to the degree of freedom 24 here, okay? If we don't go here, degree of freedom 1.65, 1.3, that is, okay, 1.318 and 1.741. So it is between these two, between the probability between 0.05 and 0.1. So the probability in this case, it will be greater than the small one and less than, no, not equal, greater than 0.1 and more than 0.05, these two numbers, okay? So it will be between them. But this is one probability, so the probability will be times 2. So it will be 0.02. This is the probability. One side, here one side only, okay? 2 tails, okay? 2 tails. I hope this one is clear also. So in this problem, what happened? A sample of 8%. So he gave me the start with the sample, n equals 8. Okay, it's taken from the population, so it's for the same population, and their blood IgM level is measured. The mean and SD of the sample, so the mean of the sample x bar and SD of the sample equals 116,055 respectively, and sigma or SD equals 50. Okay, so be careful, I don't have mu so far. So if he give me in the question itself, if he give me a new mean, okay, or the level in the population, it will be the mu for the sample. So can we conclude at level of significance 5%, so alpha equals 5%, that the blood IgM level, okay, of the sample population is equal to, this will be my mu, okay? So mu, if it's not given in the problem, we have to get it from the question itself. Mu equals 1000. So I have all the data here. I can calculate t. But before calculating the, let me look. So what is the question here? He's asking, can we conclude that at level of significance 5%, the blood IgM level of the sample population is equal to, so I used to have the H alternative equal to the proposal and H not opposite to the proposal. But here in this case, if I said that H alternative equals to, so here let me undo, okay, H not, H alternative, in H alternative we say that mu equals 1000. So I cannot solve the problem. So here what I'll do, I'll use the other way. I'll assume that each alternative, okay, is the opposite to what he's looking, and H naught, H null, okay, the null, H null is the proposal. So in this case, in order to be able, so here I'll say that mu naught is not equal to 100, which is opposite to what he's looking for. He's saying that can we conclude that at level, that the blood level of the population equals to 100. I always use the question here as alternative and prove the opposite. Okay, so here in this case, because I want to have this two-tailed in order to calculate the probability, the probabilities, and in order to get the t's and all these things, so I need to have it unequal here, and I'll put the null hypothesis as the question which I given. So mu here equals 1000. Okay, so in this type of question I put H null, the question says. So it is, if it is proven, it will be the question. Okay, and I have mentioned this initially that we can choose whatever any criteria put as H null, and the opposite or the other way it will be the HA. Okay, the H alternative. So H naught can be the question or can be not the question, or the opposite of the question. Okay, and the same thing applicable to H alternative as well. So in this case, we did not follow the normal practice which we have in the previous examples. Okay, so we did not assume that the question is alternative and H naught is the opposite. No, we said that H alternative is the opposite and H naught is what is given in the question, and we'll have the same calculation. So here mu is not equaling 1000, so it will be written like this. So I'll have two tails because it's not equal, it's not greater or it's not less. Okay, so what is the percentage? 0.5. It will be equal NT2. So here this one will be 0.025, 0.025. Okay, and I have to calculate this one. I have everything available here, so I can substitute x bar 1160.55 minus 1000, which is mu. SD equals 50, N equals 8, so I get the answer 9.8. Okay, so this is T calculated. T calculated equals 9.08. So what about T from the table? Okay, from the T table, T critical. I'll have two critical, one here, T1, and one T2 here. Okay, critical. T critical from the table, I have to go and check at degree of freedom how much n minus 1, which is 8 minus 1 equals 7. Okay, I'm going to check the probability of 0.25. So I go here at 7, okay, and 0.25, so it equals 2.365. So here critical 2.365, and here it will be negative. If I'm talking about this part, it will be negative. T1, it will be negative. Okay, and the other side it will be 2.365 positive. So 2.365 it will come here. Okay, and my T calculated is here. So this is my T critical 2.365. T calculated 2.36. Let's use the calculator. 2.365. Okay, and this is the critical, and they calculated 9 points, so 9 was be more. Okay, here, so this would be T calculated. So T calculated fall within the rejection range, so I'm going to reject the null hypothesis. So it will be, since it fall within the rejection zone, so it will be the null hypothesis, it will be rejected, so mu will not be equal to 1000. Okay, so it doesn't support or doesn't help the hypothesis which we have here, because the hypothesis, the null hypothesis this time was the same proposal here, since the null hypothesis is rejected, so this one also is rejected. So the sample is not equal to 1000 milliliter. And in this example, he did not request the probability, so we are not going to do it. It is the same way of the previous problem. Okay, thank you very much. And by having this end, we reached the end of this seminar as well.